Hello everyone. In the last lecture, we have studied different page replacement algorithm. That is your FIFO. So, what is a FIFO page replacement algorithm and how to calculate the page fault, number of page fault in FIFO algorithm, that already we have studied. But what is the disadvantage of FIFO page replacement? That will go. Then we'll go for the optimal page replacement and LRU page replacement. So already we have finished this point. So here FIFO page replacement. So total number of page fault already we have finished. Total number of page fault for the frame size 3. 15 page faults are there. Total number of page faults are 15 when you are using the frame size 3. Now in first in first out algorithm, reference string is 1 2 3 4 1 2 5 1 2 3 4 5. Now what happens here? If the frame size is 3 pages can be in a memory at a time per process. So what happens here? We can go for the FIFO algorithm for the 3 frame size. So total number of page faults are 9. Okay, total number of page faults are 9. But when we are using the frame size 4, total number of page faults are 10 page faults are there. So FIFO page replacement manifests a Bellary anomaly. More frames, that is a more page fault will occur. Suppose the number of page frame increases, the number of page fault will increase. That is a drawback or disadvantage of your FIFO page replacement algorithm. So this is your first in first out algorithm. So here we can find FIFO illustrating Bellary's anomaly. So number of page fault and number of frames. So if the number of frames increases, number of page fault also increases in a FIFO page replacement algorithm. Then second algorithm is your optimal page replacement. So the optimal policy selects for the replacement the page that will not be used for the longest period of time. Means here what we are studying, it is nothing but the future string. We should know the future string. Means the string which is we can say coming late or at the end, that string we should replace. So impossible to implement because we should know the future. So we should know that whether that page is coming futurely or not. When that page is not occurring future, then only that page can be removed. But knowing this, or we should know the future, so that is disadvantage. So it is impossible to implement the optimal page replacement, but serves as a standard to compare with other algorithms we shall study. So this is your optimal page replacement algorithm. So these are the pages 70123030, 423032, 1201701. Now the frame size is again 3. Then first one is on 7. So 7 is not in your frame, so page fault occurs. So 7, then for 0 also page fault occurs. So 1 also the page fault occurs. So total number of page fault for 3 frame is initially 3. Then next page is your 2. So 2 is not there in your frame, so page fault occurs here. Now which string we have to replace, or which page we have to replace? Now from 7 0 1. So 0 comes immediately after 2 in the future. Then 1. So we can see here 1 comes here. 1 comes here and 7 will come at the after 1. So here 7. So which string it is in the future? It is a long. Means we can say it is coming at the end. So we replace 7. So we should know the future. Means we should know the future which comes early and which come late in the optimal page replacement. So here we replace 7 with the 2. So page fault has occurred. So number of page faults are 4. Then next thing is your next page is your 0. So 0 is already available in our frame, so no page fault. Then next is your 3. So 3 is not there in our frame, so the page fault occurs. So now from this one, 201, which page we have to replace? So what happens here? We have to replace which page for 3. So 0 comes immediately, so we cannot replace the 0. Now remaining is your 2 and 3. So here 2 comes here and 3 comes after 2 here. So here 2 comes before the 3, so we replace 3. So here we are replacing 1, sorry, it comes here 1, so we are replacing 1 with 3 here, because 1 comes after 2. So here 3 will be 1 will replace by 3. So page fault occurs. Okay. Then 0. So 0 is available within the frame, so no page fault occurs. So total number of page fault currently is 1, 2, 3, 4, and 5. So next page is your 4. So 4 is not available in our frame, so page fault occurs. So which from 203, what should we replace? So 2 comes here and 3 comes here and then 0 comes. Okay, 2 comes before 3, 3 comes before 0. So we replace 0 with 4. 2, 4, 3. Page fault occurs. So page fault number 6. Then next is your 2, no page fault. 3, no page fault. Already in a frame. Then next is your again 0 here. So 0 is not available in our frame, so page fault occurs. So we what to replace from 2, 4, and 3. Here is our 0. So 3 comes here, then 2 comes here, but 4 is not there in our future sheet. Page number 4 is not in our future sheet, so we replace 4. So here 4 will be replaced with 0. Okay, so total number of page fault is now 7. Then next is your 3, so no page fault. 2, no page fault. Now 1 page fault occurs. 1 is not there in our frame, so page fault occur here. So what will replace? We are having 2, 0, and 3. So 2 comes immediately and 0 comes after that. 3 is not there in our future, so we will replace 3. So page fault will 3 will be replaced with 1 here. So total number of page fault is now 8. So 2 is there, no page fault. 0, no page fault. 1, no page fault. Now next is your 0. So 0. So what will replace? Because 2 also not comes, 1 also not coming up future. So we replace 2 with 7, because 0 comes and then 1 comes. 0 and 1 will be not replacing 2 here. So replacing 2 with 7. Then 0, no page fault. 1, no page fault. So total number of page faults are 1, 2, 3, 4, 5, 6, 7, 8, and 9. So total number of page fault in optimal page replacement is 9. Okay. So again, whether we have solved the Bailadis anomalogy problems of the FIFO. So referencing is 1, 2, 3, 4, 1, 2, 5, 1, 2, 3, 4, 5. 4 frames are there. Now if you solve this problem, total number of page fault is 6. Okay, total number of page fault is 6. So the problem of Bailadis has been solved in the optimal also. Now, how do you know the future use? You don't know. Use for measuring how well your algorithm is performed. Then third algorithm is your LRU, that is least recently used. So replaces the pages that has not been referenced for the longest time. Means the page which is not used from the longest time, that page we are replacing in LRU. By the principle of locality, this should be the page least likely to be referenced in the next future. Performs nearly as well as a optimal policy, but here we are not going for the future, that is in a LRU. So we'll see the example of LRU. So this is your same example for LRU, least recently used. So this is a reference string 701 203 042 303 21 201701. So this is your total reference string, pages in the reference string, and this is your frame size. Again, we have taken frame size is equal to 3. So initially 7 page fault occurs, then 0 page fault occurs, and 1 page fault occurs. Total number of page fault for this frame is now initially 3 are there. Now 2 comes. So which page we have to replace? So 7 was leastly used, so it was used before 1 and 0 now. So 7 will be replaced here. So we replace 7 by 2, page fault occurs here. So total number of page fault will be here 4. Now next is your 0. So no page fault because 2 is available in our frame. Then 3 is come. Now in this 3, page fault occurs. So from 2, 0 and 1. So what should we replace? We cannot replace 0 because 0 is a currently we are using. More time happens for using 1 because 2 has been used and then 1 has been used before that. So we replace 1 by 3. So page fault occurs number 5. Then again 0 occurs. So 0 no page fault here. In this no page fault. Then comes 4. Then comes 4. So what we have used currently, we have used 0 and 3. So what will replace now? 2. 2 will replace by 4 here. Okay. 4 will be 2 will be replaced by 4. Page fault occurs. So 4, 0 and 3. Page fault number 6. Then next is your 2. So in 2, you are having 0 and 4. Then 3 was used before 3. That is before 2 and 4, 3 was used. So 3 will be replaced. So 2 will be placed in place of 3. Page fault number 7. Okay. Then next is your 3. So 4 we have used currently. 2 is used. So what we have not used? 0 here. So 3 will be 0 will be replaced by 3. Page fault occurs. Okay. Then next is your 0. So 3, 2 and 4. So 4 here we have. Which recently is your 4. So 4 will replace by 0. Page fault occurs here. So total number of page fault current is 9. Then 3, page fault does not occur. 2, page fault does not occur. Then comes 1. Now in 1, page fault occurs. So we have used 2 and 3. So what will replace here? 0. 0 is recently used. So 0 is replaced with 1. Page fault number 10. Then 2, no page fault occurs. 2 is already available. Then comes 0. Now what we'll check again? 2 is currently used, 1 is used, and then 3 is used here. So we replace 3 with 0 here. Okay. So 1, 0 and 2. So page fault number 11. Okay. Then next is 1. 1 is available, no page fault. Next will be a 7. So what will replace here? 1 is used, 0 is used, 2 is used, listen. So here we replace 2 with 7. 1, 0, 7. So page fault number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So here 7. Then 0 is available, no page fault. 1 is available, no page fault. So total number of page fault for LRU is 12. Okay. Then so this is again LRU is recently used reference string 1, 2, 3, 4, 1, 2, 5, 1, 2, 3, 4, 5. So using this, using LRU optimal, total number of page faults are 8 page faults. Then next point is comparison of OPT with LRU, a process of 5-page written OS that fixed the resident set size to 3. So using the OPT and your LRU. So we are doing the number of comparison between the OPT and LRU. Then LRU and FIFO, comparison of FIFO and LRU. So LRU recognize that pages 2 and 5 are referenced more frequently than others, but in FIFO does not. So here we are referring this 2 and 5 more time. So it is used more frequently in LRU. Then implementation of LRU policy. Each page could be tagged in a page table entry with the time at each memory reference. LRU page is one with smallest time value need to be searched at each page fault. This would require expensive hardware and great deal of overhead. Consequently, very few computer systems provide sufficient hardware support for the two LRU replacement policies. Other algorithms are used instead of LRU. Then LRU implementation, counter implementation. Every page entry has a counter. Every time a page is referenced to this entry, copy the clock into the counter. When the page needs to be changed, look at the counter to determine which are to be changed. Stack implementation, keep the stack of page number in a double link form. Then we will having the page reference, which will consist of move it to the top, requires 6 pointers to be changed. No search for implementation. Then use of stack to implement the LRU. So stack implementation, keep a stack of page number in a double link form, page reference, and move it to the top. Requires 6 pointer to be changed. So here we are changing how it will change. Stack before A and stack after B. Hardware matrix LRU implementation. Pages are referenced in the order. So these are the reference. So how it will be changing in the LRU? How you refer that page in a matrix format? So this shows we will refer to the page. So here 0, 1, 2, 3. Likewise, we will refer to second page, third page in the matrix format. Then reference bit with each page associated bit initially 0. When the page is referred, it will set the 1. Replace the 1 which is 0 if 1 exists. Do not know the real order of use. However, reference byte in that second one, idea is to record reference bit at a regular interval. Keep a byte of reference bit for each page. At regular interval, left shift the reference bit of each page into the high order bit of the byte. Each reference byte gives the history of page for the last 8 time intervals. If you interpret the reference byte as an unsigned integer, the page with the lowest number is LRU page. So in this way, we have studied 3 algorithms for page replacement: LRU, optimal, and FIFO. So we'll stop here. Thank you.